Okay, so today as we continue on in lesson 1.7, we still really have the same learning goal, but today we also are going to make sure that you understand how to set up your own absolute value equations along with being able to solve them, okay? So yesterday when we were solving our absolute value equations, tell me something about how many solutions there were every time. Two. There were two each and every time, right? When you solved one of these yesterday, you got two solutions. Okay, well sometimes we have special cases of absolute value equations. Let's explore and see what else can happen when you're solving absolute value equations. So let's solve negative 8 equals the absolute value of x plus 2 minus 8. Do we need to do step A? Yeah, we do. Okay, so let's get step A taken care of. Step A says we need to get the absolute value expression alone, so what are we going to do? Add 8. 8 is being subtracted from the absolute value expression, so we're going to add it to both sides. What's negative 8 plus 8?
0.
0. The absolute value expression, absolute value of x plus 2 is now alone, so we're done with step A, aren't we? Okay, step B. This is where we do what? And we ditch those absolute value bars. We set up our special cases, our cases for it. Well, when we're setting up those cases, here's what we're asking ourselves. We need to set x plus 2 equal to any numbers that have an absolute value, a distance of 0. 0 does, right? 0 itself does. It's 0 units away from itself. Are there any other numbers that do? No, so there's no reason to set up a second one and just write the same thing again, is there? So there's only one case this time. Because because it is set equal to a distance of 0, there's only one number that has that distance. So we are now ready to solve this. We only have one case. Maybe you should write that in your notes. Only one case. And the only way we get away with that is when there's a 0 here. That's the reason why. So solve this, what are we going to do? Subtract 2. And we get our solution, which is x equals negative 2. Only one solution this time. Typically, there are 2. Sometimes there's only 1. Any questions? Okay, so this is why it's called a special case, because typically they have 2 solutions, but this can happen. Let's look at the next one. Do we need to do step A? Yeah, we do, don't we? Okay, so what are we going to do in step A? Subtract 3.
What's step A here?
Getting the absolute value expression by itself. Okay, so what do we have now? We do have the absolute value of x plus 4 alone now on that left side. And what do we have on the right side?
Negative 2.
Negative 2. Okay. We're done with step A? Yeah. Okay, let's move on to step B then, where it says set up the special cases or case. What we need is we need to set x plus 4 equal to any number or numbers that have a distance of negative 2.
2.
Oh, 2 has a distance of negative 2. Negative 2 has a distance of negative 2. 4 and 0. 4 has a distance of negative 2. 0 has a distance of negative 2. Did we ever talk about distances of negative 2? We talked about this yesterday. Did I throw up yesterday somebody lives south of town on Catherine Road, and they live out, let's say 5 miles south, so it's going down. Or if you want to think of the number line, you know, when we go to the left, that's going west on the map. So if you live west of town, you live a negative distance from town. If you live south of town, you live a negative distance from town. No, we don't talk about distance as negative. Even if you're backing out of the driveway, you're not going a negative distance, you're still going a positive distance, you're just backing up is all. That's what's happening. The car does not roll the miles back up Actually, they used to do that. They actually did. Cars used to, years ago, when you drove in reverse, the miles would come off of the odometer. Yes, Ben?
We've seen Ferris Bueller's Day Off.
Is that happening then?
They tried to make it work, but it didn't work, and they ends up crashing their car.
Oh, yes, but people actually used to drive around in reverse. Like if you're, let's say your parents gave you the car for the night, this was before you guys all had your own. I didn't have my own car in high school, I got to have my parents' every now and then. And when I did, they would be like, you're not putting any more than 10 miles on it, let's say. And then it's just to have it for a little bit. So if I put more than 10 miles on it, I could put it in reverse and drive those miles in reverse, and it would take those back out, those extra ones. So, but in reality, there is a negative distance. So in this case, we have to stop and say right here, there is no solution. Oh, no, here's what we're going to put in this in part B. I'm sorry. Can't have negative distance. We just don't talk about distance as being negative. Distance has length and it has direction, but the direction we don't take care of with a negative sign. So we move on to step C and we say there is no solution for this one. We would never find a value for x that would make that equation true. No matter what we put in there, no matter what we put in there for x, I don't care what it is, positive, negative, fraction, decimal, zero itself, no matter what we put in there, once we take the absolute value of that number that's inside there, it's got to be a positive or a zero. Distance from zero, it has to be a positive or zero, and this is saying it has to be a negative 2. We can't have such a thing. So these are our 2 special cases. So now we have 3 things that can happen. We're solving these, and we can set up 2 cases. We're solving these, and we can only set up 1 case. We're solving these, and we can't set up any cases. And we end up with a no solution. Okay? So when do you think the 2 cases are going to be? When you have, after step A is done, you've got step A done, what's got to be on the other side for there to be 2 cases set up? A positive number. Yeah, a positive number. What has to be on the other side for a 1 case to be set up? 0. What has to be on the other side for there to be no cases? A negative number. So keep that in mind. That once you have step A done, or you get to skip step A, and you're moving on to step B to set up your cases, that's what should happen. When there's a positive number, you should be able to set up 2. 0, only 1. And a negative number, no cases to be set up. Okay, write and solve the absolute value equation to find the following. So now we're going to learn how can we set up, we got to learn how to set up our own. So we have this thermostat that is set so the temperature in a laboratory freezer stays within 2.5 degrees Fahrenheit of 2 degrees. So the ideal temperature is 2 degrees Fahrenheit, but it can vary by 2.5 degrees Fahrenheit. It's kind of like that contestant guessing yesterday. They varied. Each of them guessed $15 off, and it went 15 either way. So what would be the maximum and minimum temperatures if 2 degrees, this is where they want it to be. This is where they want it. But it can vary, stays within, that means it can vary by that much. So what would be the maximum? What's maximum mean? The most, the highest, yeah. And minimum? The least, the lowest, okay. So what would they be? Okay, well, what did I hear, 4.5? That's adding. That'll give us our maximum, right? So, look at me, I so nicely set up our number line for us. What's the minimum? 2 degrees, can vary up to 2.5 degrees going this way. Negative 0.5. I just set you up for it here. Okay. Well, now we need to write an equation that represents that graph. So, this middle value, or the starting point, what do they want it to be? 2, okay? The distance that it can vary by is how much? 2.5. So here's our model. This is the model. You know what? Put in big letters here, model. When you need to set up your own absolute value equation, this is what you do. You say, you know what? I need to subtract the ideal value, the middle value, what they want it to be value from x, my absolute value, and I need to set it equal to how much it can vary by. You can go a negative 2.5, it can go a positive 2.5. So I set it equal to that number, to show distance. So anybody have an idea what this equation could look like? Go ahead, try something on your papers. Take your pencil and do it. Don't, not gonna spoon feed you. Try it. Okay, share. Either me or somebody, share. Austin, you share with me, thank you very much. How many of you have that same one? That's your equation. Yeah, that's the right one. That's the right one. This is saying it can vary by this much, so we know that there's two numbers that have that distance, so it can go up 2.5, it can go down 2.5 after we get rid of those absolute value bars, which we would be able to do right away in this one when we were solving it, wouldn't we? Okay. So you know what? Let's try and find. Do you have enough room, or is this the bottom? Can we solve it? Okay, we'll do that on the back then. Do you think this one would solve to give us negative 0.5 and positive 4.5? Well, let me show you that it will, even if you don't have room to put it on there. Okay. X minus 2 equals 2.5. And in other words, I get to skip step A. Step A, and I can put, because this is a positive number, I can set up two cases, and my two cases are setting that equal to a positive and a negative 2.5. I move on to, that was step B, I move on to step C, which says add 2 on both sides. And what happens over here? X equals 4.5. Oh, well, look at there. There's that one. X equals negative 0.5. Look at there. There's that one. So our equation should solve to make sense to what we think the answer should be. Okay? So otherwise, we haven't set up a good equation. Okay, let's go to the back side. And let's try what they want us to do back there. I think this is where you need your book. Yeah, we need to go to page 57. This is actually a problem from the homework set, but not any homework you have to do. It's just one like some of your homework. So, number 13. Okay. Page 57, everybody's book is open to it. Number 13 is a word problem. Go ahead, read it to yourself and see if you can come up with the answer without even writing the absolute value equation. See if you can come up with the answer, and we'll just graph it right away. Go ahead and graph what you think are the solutions for this, or the maximum and the minimum values. Reminder, 0 does not have to show up on your number line. It's okay. 0 is part of the number line, but it's not the most important number on there. Sometimes we think it is, but... Okay, just out of curiosity, what number would be a good one to kind of put in the middle of our number line picture here? 207, yeah. How much can it vary by?
2 miles.
2 miles. So I could, go like this and say 2. So what's the minimum?
205.
205. What's the maximum?
208.
209. Oh, that seems like a no-brainer, doesn't it? Okay, so to go ahead and, put some points on there. We believe those are the solutions, the minimum and the maximum. So now we have to write an equation. So go ahead and try that. Write an equation. I kind of helps set you up. I say middle value is distances, because remember we got that model. So write your own absolute value equation for this, and then we're going to solve our equation to make sure we really do get 205 and 209. Okay, who's the brave soul is going to share their equation? Thanks, Avery.
Line x minus 207.
The line, what is that line?
Oh, that's the value.
Thank you. Absolute value of, what did you say?
X minus 207
Okay.
equals 2.
Anybody agree with that? Because why? Because the middle value is what? 207. That's what we want it to be. That's like the starting place. What can it vary by? Or in other words, what's the distance? 2. So once we identify what is the ideal, where do they want it to be? What's the middle? And then once we decide, well, how much can it vary by? What's the distance it can go either direction from that? We can set up our equation. Okay? Good equation. Do we need to do, we're going to solve it now. Do we need to do step A? Okay, we get to skip A. Moving on to step B. It said equal to a positive number. How many cases will there be? 2. 2 cases, positive number. So we're going to have x take away 207 equals what? 2. And what's our other case? -2. Going the other direction. The other number that is 2 units of distance. Okay, that's all we do in step B. Step C, do we need to solve? Yeah, we need to add that 207 to both sides. And for this one, we get x equals 209. For this one, we get x equals 205. Same thing that we said when we started it, doing it without setting up the absolute value equation. Because these are easy ones, as far as, like, well, I can solve this problem without the absolute value equation, but we want to make sure that we know how to set them up and work with them. So our minimum mile marker is 205. Our maximum mile marker is 209. Okay, anyone want to ask questions on that one before we move on? So when it says in the directions like it did in this one, it said write and solve an absolute value equation. Did we do that? Yeah, we did. We wrote our equation. We solved it. Okay. Now let's do the reverse. We got the graph already there for us. We don't have any idea what this graph represents. It's not really the reverse, but basically we're doing the same thing we did with those mile markers. We graphed them first, but we knew that what that was representing. Here we don't have any idea what this one's representing. We just know that these are the solutions to an absolute value equation. So what are the solutions? Are x equals 1 and x equals -5. Okay? That's a funky x. And x equals -5. So those are our two solutions. So basically what we're going to do is we need to set up an absolute value equation that when we're done solving it, that's what we get. If we set up a good absolute value equation, after we're done solving it, that's the solutions we should get. So go ahead, from your number lines, get this figured out right here. Determine the middle value and the distance. So use your number line, it's already there for you, the solutions are graphed on it. Determine the middle, the distance from that middle up to the solution, and then write your absolute value equation. You get the same middle value I do, same distance I do. What's the equation?
X minus 2, the absolute value.
Okay, the absolute value of x minus 2. It's -2, so it really starts out like this, doesn't it? X subtract the middle value. That subtraction does not take the place of that negative sign on the 2. -2 is our middle. So that starts there. And it's equal to what, T? 3. Okay? Now, we'll clean that up. I heard somebody say it's really x what? Plus 2, isn't it? Because subtraction can be changed to add the opposite. So the subtraction sign would become an addition sign. The -2's opposite is +2. So we can clean that up and that can become this. There's our equation. That's how we would see it written in a book. We wouldn't see it written, the absolute value of x minus a -2. Okay, do we need to do step A? Okay, we get to skip A. Move on to step B. Step B says, how many cases should we be able to set up?
2.
Why? There's a positive number over here. So it's going to be x plus 2 equals 3, and x plus 2 equals -3. Go ahead and solve those. Our next step, solve them. And do you get the solutions that were graphed on the number line? You sure do. That's awesome. We have a good equation. So even if they don't tell you to solve your equation, all you do is say write an absolute value equation to model this. You know what? Without taking the time to solve your equation, you're not really making sure that you have a good equation. You're just happy to have something down again. Okay? I don't want that to be the case. Okay, anybody have any questions?